Hello, my name is Ryan Page and I'm an application specialist for Tekla structures. Today in this video we'll be discussing modeling and quantifying basic joints in Flatwork. For this video specifically, we'll be covering the following key points: the methods that are available for creating joints in Flatwork. Then we'll also discuss how to use them effectively and things to consider such as naming and material. We'll also demonstrate how to create multiple joints quickly. Lastly, we'll build upon the second topic and we'll use the organizer and make some quick adjustments to get the information we need from our joints. So with that, let's begin. Okay, so for this video, I've created a new model using the cast in place rebar detailing template, and I've gone ahead and laid out some odd shaped slabs, similar in profile, but just slightly different dimensions. That way we can get a little variety when we inquire upon our joints later in the video. The idea here is that we will first step into modeling a concrete joint and cutting that concrete manually. And then we can look at a tool that kind of expedites the process for us. Essentially what we're after for any flat work, or any concrete for that matter, in creating a joint or a mock joint or anything like that, is we want to create a piece, usually using the beam tool, and then cut the slab or other piece of concrete, whatever needs the joint. And then you have not only a cut, which helps your volume, but then you can also use that beam you created to quantify. That's the general principle. So let's take a look at how that's done manually. So we'll go up to the concrete ribbon and then the beam tool. I'm using the standard beam tool, but feel free to use the poly beam if you so feel the need. What I'm going to do is just update a couple of my general properties before we go ahead and create the beam. So I'm going to call this control joint beam. I want it to remain different and unique from other beams in my model. I'm going to change the profile here to be something a little bit more respectable to an actual control joint. So I'll do 2 inches deep and we'll say a ½ inch thick. I'm going to change the concrete material from 4000 to concrete undefined. This will help keep some of this will help keep the joints separated from the concrete and not merge. I'm also going to make it visible for me. Since my slabs are blue, I'm going to pick a contrasting color like yellow, so class 6. And then just for good measure, I'm going to put this on pour phase 2. Typically speaking, slab on grades typically would have a pour phase of 0 or 1. So this will help also keep it from merging. So once we have these, the last thing I'd want to populate is down below under the UDA's drop down where it says design name. I'm going to just pop in control joint as well for the design name. And the reason I'm doing this is that up here, when we include the word beam in our name, it allows Tekla's default templates to automatically pull this and report upon the control joint as a beam. However, we may not want to call it control joint beam in our reports and tables and things like that. And so we can call upon the design name instead of the true name. So this allows me to use existing filters and features, and this allows me to call it whatever I wish, wherever I want. So now that we have that and our settings are good to go, I'm just going to arbitrarily first pick a point. The idea here is to draw a joint here between these two grid lines. I'll use the midpoint, snap perpendicularly, and draw the beam. Now we can see here, nothing has happened except I have a piece of concrete inside of a concrete, and the next step would be to go to the edit ribbon, then select part cut, and then follow the prompts down in the bottom left, select the objects to be cut, which is the slab, and then the cutting part, which is the beam. There we are. And so that's going to go ahead and create a cut for us. We can turn things transparent, and we can see the beam, the joint that we have made. We can right click and hide it, and you can see the cut. And it's part of our slab. This will update our volume, and then we have an actual physical piece that we can also quantify. That means we can call it something, we can get its linear footage and its dimensions, and if you needed to, surface area or volume, and then you're able to go ahead and continue to do this and repeat this process or copy it into place wherever you see fit. So the basic method we just covered is really great if you need to just put in a quick one-off joint, or you're really trying to master how other tools may go ahead and automate some of this process for you. That's one of the reasons why we show the manual way. But with Tekla, we have loads and loads of tools and components that help us expedite these processes. So let's take a look at one that I think is most suited for joints in concrete flat work, particularly cast in place. So we're going to go over to the side pane here and open up our applications and components side pane. And then we're going to search for geometry. And what we're looking for is the geometry detailing strip tool right here. If we open and double click that, we're going to get ourselves a dialog box. As a quick introduction, if you're unfamiliar with the tool, this tool is very handy for adding different types of concrete geometries to your structures, whether it's brick ledges or keys or any sort of kind of notch or that sort of thing. This tool is utterly fantastic. You have different options to apply and then use the fields to provide the appropriate dimensions as you see fit. There's a couple other options we're going to touch on here in just a second, but let's talk about just what we need to do to get a basic control joint, similar to the one we already modeled, into our slab. So let's go ahead and then use this by default, right? This mock joint here. And let's go ahead and make sure that our C dimension is 2 inches deep. Our A dimension, which is the width of the cut, we're going to make that a 1/2 inch as well. The other ones, B and D, we don't need our taper. Although if you did, you could leave it, but I'm going to zero those out, okay? And I'm going to apply those settings. So the way this tool works is you activate it, apply your settings, and then you come in and select the concrete face you would like to apply. In this case, the top, as you can see here. And just like before, we'll go ahead and snap to the middle here, and we'll create one joint. Now, with this tool, I created from the bottom going to the top of the slab. The direction you create this in does matter, especially when it comes into arraying these later. So we'll take a look at that. We could always undo, and I think from best practice from the top down. There we are. But it creates another joint. Now, it hasn't given us a cutting part. It's just created the hole. And that's the way the tool is configured, right? At least by default. But what we can do is kind of update this or change some of our settings here to give us some better results. So by default, we'd want to go ahead and have the part and the cut made at the same time, not just the cutting part. So we can hit modify, and that's going to give us a piece, just like we saw up here. Now, the thing of it is we don't have any way to control the properties of that beam in this dialog box. But what we do have is the ability to use a preset. Now, by default, it'll use the properties of the concrete slab or whatever we're attaching it to. And we don't want to do that. We could just use a beam and apply those and modify it. And that's going to change the look here a little bit. But what we could do, I think as a best practice, is come in to select this previous beam, come to our properties, and save this as a control joint setting. So I'll just name it CIP underscore, we'll just call it joint, and we'll hit save. Right? I'm going to close this dialog box and then come back to my applications and components and reopen the tool. Now I should be able to find CIP joint. Okay, so let's go ahead and select this and hit modify. Ooh, let's make sure we're using the cutting and the part. There we are. Well, this is turning out to be pretty good. So now if we select the objects within the component, it's going to have all the same properties that our other beam did, but now created with the component. Ooh, that's the cut here. That's better. Perfect. So with that said, we can use this to our advantage. I would save this configuration in the geometry detailing tool as a CIP joint as well, so I don't have to recreate this and use it as a starting point. But that's pretty much as simple as it is, right? To dictate the parameters of the profile of your cuts, make sure that you are not only applying the cut but creating the part, and use an existing preset to name the beam or joint as you see fit, because we'll need that to quantify. Now, if you're familiar with Tekla structures, there may be a couple other tools that come to mind that could help you achieve joints. And if you're new to Tekla, then you may discover these along the way, and I just want to address a couple of them. First and foremost, in the environment, we also have a saw joint tool. Now, this tool is pretty good, and it creates similar results that we have just been demonstrating: the profile, the cutting part, and as well as the cut itself. And you can even define some of the parameters here right in the tab. But the problem with this tool is it creates a precast piece of concrete. And if you're using the cast in place detailing rule, that's not going to play well with a lot of the default settings, such as reports or the organizer and things like that. And so although you can use this, it will require you to manually edit the cut piece by selecting objects within components and changing the cast unit type from precast to cast in place. So that's why we're not really covering that per se. The other tools worth mentioning are the concrete modeling tools. Now, these are not downloaded with the environment for cast in place, but they are available on the warehouse, and you can create several types of joints, slab control joint, reveal components, as well as openings and composite slabs, mock joints, and that sort of thing. Again, these tools are pretty great, and they're often used in some of the precast modeling, but many of them do not create the cutting part. And we will need that, as you're about to see in the next couple of sections. So for that reason, we're not recommending these for this specific task. So now that we're able to model a joint, either manually, as we did up here in the top, or using the geometry detailing strip component, as we did down here at the bottom, what do we do with this? Well, we can run a report or open up the organizer and quantify it, but most likely you're going to need these joints spaced evenly throughout the rest of the slab. So let's take a quick look on how we can use what we have here to do that, and it'll end up painting a picture, I think, that the geometry detailing strip is the way to go. But let's start with the manual cut that we made earlier. Remember, we go ahead and modeled a thin beam and then cut the concrete around it using part cut from the edit ribbon. Well, we can copy this, and we can use this using the copy special linear tool, which allows us to populate a distance and then a number of copies in that distance, so it'll kind of array it for us, but they'll remain independent. The key to this is making sure that you're not just selecting the concrete part, but you're also selecting the cut itself, which is seen here with the hidden line outline here. So we need to make sure that we're selecting both. Otherwise, you're going to have to cut the concrete several times if you forget to grab that. It is not typically visible in your view, so you need to turn it on in the view display properties. Two ways to do that. The contextual toolbar for the visibility options, drop that down, and then you can select and turn on cuts and added material. Both eyes you want to click, or you can double click into the empty space of your view, hit the display button, and then come down and check these boxes and hit a modify. Remember, this is view specific, so each view will have to have this done if you want to look at it in more than one view. But once you do, it's pretty simple. Go ahead, turn your concrete transparent by hitting Control-2, select everything that you need, deselect the slab, right-click, copy special linear. We'll say 15 foot and a number of copies for 4. And we'll go ahead and hit the copy button. That does place them, but notice they're not dynamic to the shape of the concrete, right? Our cut stops here at the grid line. It doesn't extend into the larger, wider section of our slab. And so this method, the manual method, is always going to require us to manually edit. There's a couple of ways you can go about this, but if you're thinking about it from a straightforward perspective, you're going to basically need to grab this or select that piece and then basically drag up, snapping perpendicularly. That'll be the cuts, and then we'll need to do that same process for the actual beam. The center point is the one you want to grab, not the end points on the beam from the plan view. We'll just come up, and I'll zoom in so you can see me snapping. There we are. So a little cumbersome. In fact, it may behoove us to select this one, deselect the slab, delete it completely, and then copy this one over just once. It's probably less cumbersome. There we are. So you can kind of get the idea there. In a pinch, or if you're not wanting to spend a lot of time with the geometry detailing strip, or you're only doing this for a very small section, maybe this is all right and the way to go. But if you're working on a lot of flat work on a project, or if you establish some settings with the geometry detailing strip, I think it's going to be the better way to go, especially when it comes to placing these joints throughout an entire large area. So if I double click on the one that we've placed, I can bring up the dialog box, or I could do it from the icon here. But the only thing that we need to do is really expand upon the settings we've already gone ahead and applied here. So I'll load up our joint preset that we created before so we can update it. But essentially what we can do is provide a spacing value. So if I said 2 spaces, so 2 asterisks and then 15 foot and hit modify, it's going to go ahead and give me, well, it looks like it gave me 1, and there's a reason for that. You see, it is using this insertion line, and it is equally distributing those 2 spaces to the right and to the left. The problem is this here is not 15 foot off the edge, so we don't see it. If we were to select it and then hit move and then say just drag along here, eventually you would see that other one pop up, right? Now, not everyone's going to want to go equally to the left and to the right when they start to provide spaces, and you can control that in here from this drop down, either the middle, the left, or the right. If it's left blank, it'll default to the middle. So if we did to the left and then hit modify, now notice, here we are. Now, just like our manual method up at the top here, our our joint is not extending the full length of the slab, or the full width, I should say, right? So how do we address this? Well, I'll show you a trick. If you have a configuration where you have one contiguous piece of flatwork here, and you're going to use the geometry detailing strip to apply said joints, instead of modeling the joint on the thinnest portion, do it on the thickest. So if we delete this, apply our settings, come back over, and activate our tool, select our face again, and then go from start end point there, middle mouse click. Now what we have, as you can see, is it's populated these for us based off of the tool's applied settings. We bring that back up, it's going 2 and 15. So notice that it's always placing the joints to the left. You can also do it to the right and hit modify, and it should switch sides. See, there we are. But notice now it's adapting to the thickness. Now the secret is to move this first one into our starting point. So we can simply just select it, hit move, and bring it to the point we want, and then update this, saying to have 4 or 5. If you put too many spaces, it will only populate the ones that are visible through the slab's boundary. So you can see here that the detailing strip, the geometry detailing strip, provides an advantage when you are placing more than one control joint. And although we covered the basics and you understand how the tool is and the joints are being created through the tool, using the tool actually provides you a distinct advantage. And it's recommended that you use the geometry detailing strip for any kind of joint work, whether it's just a control joint here or a full cut through, because you can always modify that to the thickness, right? There we are, and split your slabs that way. But either way, this tool is where you want to end up, especially when it comes to your arrays. And you can just choose right or left or middle from what side it'll populate those spaces. Remember, it's the number of spaces and then the distance of that space. So, and you can also do variable ones. If we wanted to do 2 at 15 foot and then 3 at 20 foot, we could hit modify, and it will adjust those. Remember to make sure you have your positioning correct. There we are. All right, so the last bit of this video that we want to get into is quantifying these joints. Now, I want to preface that we haven't talked at all about using, say, pour breaks, which you can apply to either when pour view is turned on for your concrete or not. And it's really easy to kind of drop them in. The reality of it is, though, is that pour breaks don't provide us with some of the physical data that a beam would, including a thickness and or linear footage, right? So it doesn't become very useful for us in quantifying the amount of saw cuts or material that is required for our joints. And so that is why we haven't touched on that. So that's why we use the beam method with the geometry detailing strip. Now, how do we quantify this? Well, it's the same way you would quantify anything, either through the organizer or reports. We'll focus on the organizer here because it's quick and easy to show how to work with that. And you can use the same attributes that we call out in the organizer to update your report templates. So let's go to the Manage ribbon and open up the organizer. So here's the organizer. For those who are uninitiated, the organizer is a quantity tool as well as a quality control tool. You sync with the model and it displays objects based off of filters into categories, and then you've used the data associated with those objects here in the property browser, the object browser, sorry. First thing we do is a sync, hitting the sync symbol here, the sync button to bring up and sync the organizer with our objects. So this is going to provide us with a few things loaded into the cast in place category here, the drop down. We're getting, as you can see here, several lines for control joint beams as well as slab on grade. We can use the subcategory here on the right hand side to kind of narrow that down. So let's take a look at some of the data that we've got. Initially speaking, we can look at how many of these, it's combining identical rows, the prefix which is used on that, so B for usually for beam and S is from the other tool, the material, volume, pour phase. This is not initially that helpful for our control joints, right? We can try to look at another drop down here. Perhaps default would probably be useful, or parts. Let's take a look at that. So we have the profile, the material, the finished class. That's useful but not helpful. What we're really looking at is the size of it, right? Either the profile or its overall dimensions, as well as its linear foot. And that's really what we're after. And so default gives us some of that, right? Control joint beams, we can combine some of those. but it's got some information here, some fields that's keeping things from merging in the organizer, right? So we're not getting a quantity of 2 or 3 unidentical because some of this information, such as the part position or I think an item ID, is going to cause us to be slightly different. So what information would we want? Assuming we want to know what it's called, what the material is if there's a material applied, as well as its overall dimensions, length, width, depth, and its height. So all of that, linear footage and that sort of thing. So we can use this as kind of a starting point and create our own property set for the object browser. And I want to show you how to do that for control joints or joints in general. If we hit the settings button up here, we can always go ahead and load a property template. The properties that we are loading or the attributes are listed here on the right-hand side. We can create a new template, either a blank one or from the current one. We'll use the current one to help populate some things, and we'll just call this joints. We'll hit create. So now we're working with a template called joints, and we can start to eliminate some of this information we do not need. So the object type is not necessary. We can get rid of that. We also don't need the part position. The ID, certainly not. The profile could be useful. However, I would say that we just want the overall dimensions, so we'll add those instead. The material we'll keep. And top and bottom level, if you need to know the top elevation of the joint, sure. Length, width, and height, we certainly do want to keep. The weight is not useful for us at this time, and I don't think we're going to worry about the volume or the phase. Right. So as we're doing this, you can see that this is updating here. I'm just going to hit modify to save my progress, and then I'm going to update some things here. So first and foremost, I want to look at some of the units that I'm using. Now, I like decimal feet for the overall linear footage, but I want to look at its units. So we're doing foot with the precision of 2 decimal places, which is great. In the sum rows, we are getting a result, but in the combined row, which is showing a count, so this is a combined row, it's not giving me the result, just a single value. So I'm going to change that to result and hit modify. That way, it hopefully will give me a running total of all the linear footage. Now for width and height, I may actually prefer to have that into foot inch. We'll set the precision to a 16th, but you set it to whatever makes most sense for your workflow and your company. Hit modify. And if we come over here, you can see things starting to update. So now we have a true total linear footage for 2 items with the width of that joint is as well as the height or its depth. So we have some 6-inch deep ones and some 2-inch deep ones, if you recall. So you could then change the names or the headers. You can put, instead of all caps, you can change that as you see fit. We'll hit modify, and then that updates, as you can see here. You can rearrange these, which I often find easier to do. And if your data disappears because you've updated, just hit the refresh button here, and it'll bring it back. But you can change the position or the orientation of these by dragging them out and placing them in between. So the choice is yours, how you want to organize that. You can always hit modify to save your changes. Now, one thing that we talked about earlier is not wanting to pull the control joint beam, the name of the beam. We wanted to just say control joint. Well, we can update that. Instead of using name, we can search for design name. And you're going to want to remember to use an underscore between the words. And for the purposes of the organizer, you're going to want to use the one with the UDA dash in front of it. And we can just drag that in there, and then delete the name and hit modify. There we are. And then let's refresh. See, now we have control joints. Now, for the parts that didn't get that populated, right, and oops, maybe that was a human error or the tool didn't cooperate, we can actually select these, right-click, select in the model, and bring up the properties of those parts. And come down to the design name and hit control joint, and then enter or modify at the bottom, and then we can refresh. So what the organizer allows us to do, not only in reporting the quantity, but allows us to quickly interact with these objects, multiple objects at once, edit multiple objects at once because it's easy to select. But we have running totals at the bottom. So I have 175, almost 176 linear feet of control joint that I need to worry about. And we can kick this out to Excel with 2 clicks of a button. We can share that with anyone that we need to. Now, here you are. It's just static in Excel. It's not formulaic, so you can copy and paste it. But if you update and change, just re-export and save as. But with that, we're going to go ahead and conclude this video. This concludes our video on modeling and quantifying basic joints in Flatwork. Thank you for watching. Want to learn more about this topic or how to get started with Tekla structures? Just check out this video's description for links to our user assistance page, Getting Started Guide, and our online campus.